So let's see if we can see some progress here. Can we build this without audio support and networking? NetPlay, NetLogic, NetScore. Looks like probably not. I think we have to do this the hard way. Go back and undo our checkout. SDL2. So once upon a time, we had non-network logic, but it looks like the old path is no longer here. So let's start in on audio. So audio spec no longer has a callback. That's correct. Ryan is so much better at this than I am. But we have a migration guide. Audio callback. The primary way to play audio is no longer audio callback. Instead, you bind audio streams to devices. However, there's still a callback method available if needed. So that will simplify our porting. So let's use that. In SDL2, you might have done something like this to play audio. You have a callback. You set the callback and the user data. In SDL3, you can do this. We open device stream with audio device default playback. We have a spec, we have a callback, and parameter. Okay, so we can still use our callback. Spec size is also not used. Let's see if it talks about that. Size. Audio spec. The old example doesn't actually set the size. What if we did? SDL3 now manages the remove samples field. They aren't relevant anymore. But we actually use it. Let's think about this for a second. So this is our August audio thread. The callback is null. We don't do anything. Interesting. When would callback be null? Oh, this is actually a thread. If the volume is 0, we create a bogus audio thread. That seems silly. Let's come back to that. Spec callback will never be null. Interesting. Let me just verify that. Nope, never null. Okay. It's fun. In the porting process, you always go back through and find things that were silly in the original coding. There was a reason, no doubt, in the ancient past why that was important, but that's been long since removed. Okay. So what were we doing? We're grabbing the wave format. We're setting the samples to this 1/30th of a second. So 1/30th of a second is approximately 32 milliseconds, 33 milliseconds. 33 millisecond buffer. I wonder if we have to care anymore. Well, let's see where we're initializing audio. actually in the volume call? It is. Look at that. I'm going to remove this bogus audio thread. It's okay if we mix audio with volume 0. We didn't do that in the very long past because performance was critical, and not mixing audio is better than doing it. But I think that's okay here. So instead of doing it in the volume call, let's do it here. So go back to our migration guide. How do we do this? Okay. I think we actually added resume audio device stream. Let me check. Nope, guess not. Pretty sure we did. Include STL3, STL audio.h, resume. Resume audio device. Resume audio device. Resume audio stream device. Aha, there we go. We should update this migration guide. So we've got pause audio stream device. Let's grab our code again. Okay, so we have our spec. We've already filled that out. Our callback is fill audio. And our parameter is this. Looks like the parameters have changed. Let's see. Yeah, so our callback now takes this stuff. So we have our user data. We have an audio stream, an additional amount, and a total amount. So additional amount is how much we actually need, and total amount is a recommended value to keep the audio flowing smoothly. So fill audio U8 stream len. What does that do? Audio U8 means it's unsigned 8-bit audio, which basically no audio device is going to use. So SDL is going to be doing some conversion for us. But let's see what we're doing here. While len, look at the sound channels, and we update the value. It's an interesting note. We're calling callbacks internally here if we need more audio. That's fine. So I don't see anything that is reliant on the amount of audio that we're going to mix. So we're going to try, at least for now, we're going to try just mixing the amount that is requested. No, let's do the total amount. All right. So while int len equals total amount, while len greater than or equal to, how much do we want to fill? Let's take a look. So our calculation is that. You know what? Screw it. I'm just going to fill in the amount that's left. So unit 8 stream equals a additional amount. We call fill audio stream with that amount. I might be revisiting this. Okay, and then we have to, oh, it's already got an example for us. Let's do this. If additional amount is greater than 0, okay. If additional amount is greater than 0, we stack allocate it, we fill it up, then we put, yes, this is data because stream is already a different parameter. And there's additional amount. Again, we might be coming back to this, but that's fine. This will get us going. And I'm just going to if0 this so that we have it for reference if we need to change our calculation later. Okay, so we have our audio device stream. We're actually going to need to remember this. So we'll save it as a member variable, and then while we're here, string. And since this is a member variable, maxSound.h. Let's see, we've got our spec, channels, playing. We don't need bogus audio anymore. STL audio div stream. Stream is no winner. Interesting. Wow. Okay. Bogus audio. Okay. So stream. Resume audio device stream. Actually, we want to wait until we set the volume before resuming it. Volume vol, halt sound. Okay. That wasn't too bad. Let's review this code. Okay, so now we need to go back to our volume function and keep it from doing lots of opening and closing devices here. So active equals playing, volume, clamping the volume there. We're not going to do anything in the case where volume is 0. Also, yeah, this gets much simpler. All right. Do we need the distinction now between active? No, we don't. Equals playing. I'm just going to say playing is always true. Let's say u and 8. Are we actually just using that as a bool? Let's see. Playing We are just using that as a bool. Ah, the good old days. All right, let me just fix that. Actually, we are always going to be playing. I'm just going to remove that. Then here, we're going to be doing close audio device stream. The naming convention is nice. Device stream. I spoke too soon. Haha! How do you close this? Destroy audio device stream. Haha. And if something failed, this will be null and the destroy call won't do anything, and that's fine. Okay, so we don't need active or playing. We're just going to clamp the volume and set it. And return the old value. Yay! Play sound. Okay, let's see how that goes. Oh yeah, our bogus audio thread is gone. And we don't need extern C here because we're using SDL call, which is extern C, cdecal. Setting samples. Why are we setting samples? This is where we're loading the audio. We're no longer using this data at all, so that's cool. All right. P is an unreferenced local variable. Yes, it is. Missing type specifier. Oh yeah, this is networking. All right, let's come back to that. Okay, it looks like our audio indicates stack failure by raising the stack overflow exception. Do we want to catch that? We probably should. Normally I build without exceptions, but we'll make an exception. Maybe not. We'll come back to that later. I happen to know that the amount that will be requested is going to be on the order of 4K, and there will be plenty of stack. Okay, so now we're on to networking. Okay, so this is not anywhere near release yet, so there probably isn't a migration guide, but let's just double check. SDLnet. ls. Oh yeah, there's not even a docs directory. All right, so let's do it the hard way. Let us open up the include file and see what's in there. Okay, so the first thing it's complaining about is UDP socket. So, full disclosure, I have not even looked at the new SDLnet API. So, I'm doing it without documentation and without any prior knowledge here. So let's see what it looks like we're doing. So there's some address functions. Stream socket, that's a TCP socket, okay. We don't want a TCP socket, we want a UDP socket. So we're not going to do any of this TCP stuff. Right to stream socket. Yep, we don't need any stream socket. Datagram socket, that looks promising. Looks like that's what it was renamed to. Okay, so let's change this to that. Guess it's just that one place. All right. Let's change. Let's see, datagram. Looks like replaced UDP packet. Okay. Going back to addresses, I saw some address functions up here. An STLNet address. Okay. Hopefully, this will just be a simple renaming. Okay. What is a socket set? Select. Wait. Wait until input available. Datagram socket. Is there even such a thing as socket set? Looks like that's been replaced with wait until input available on a number of sockets. Okay. So let's just throw a couple of void pointers in there and see what happens. That will certainly not compile, but that's okay. Okay, alloc packet, alloc. Receive datagram, send datagram, create datagram socket. Is there a way to allocate? Let's destroy datagram, create datagram. How do we allocate these? Receive, destroy. Seems like maybe this might be a flaw in the API. Or maybe if you send them, you just inline assign values. Let's see. Receive datagram, send datagram. Let's look at the examples and see how send datagram is used. Let's see, we have examples. Voice chat. So, scratch area. Oh, we don't use the structure at all. We just use the address, the port, the data, and the size. Okay. I did not see that when I was looking at the header. Let me look at the header again. Yep, there it is. Okay, so we don't need outbound data, although I think we want to use it just for our sanity because we're keeping data structures there. So we'll create our own STLNet alloc packet function. Let's see if it's already in there. Alloc. Receive datagram. Pump datagram. How does it fill that in? It just mallocs it. assigns it, sets the field data. Okay. That is a handy trick. Okay, so we'll just write this function. So we want STL datagram star. And here's our function. And then we'll take a size t size. And then packet equals STL malloc. So we want to do size of packet plus the size that we're getting here. So we can do it all in a single allocation. Then if packet, we're going to zero the packet. Actually, we can do that in the using calloc instead. Let's do that. Calloc. The parameters are number of elements and the size. So now we don't have to zero it, but we still need to assign buff and bufflen. So that's a cool trick. Let's just steal that. Packet equals packet plus 1. Then bufflen equals the size. And then we'll return that. And then we'll make this static because we're not using it anywhere else, I think. Let's find out. Yep, right there. Okay. So data has changed. It's buff and bufflen. Okay. Resolve host. Come back to that. And we'll resolve host. We already know how to handle this. Okay, UDP open. Open. Let's look at the header again. Create datagram socket. Okay. So the port is, it doesn't say whether or not it's native Indian or not. Or does it? Let's read this. Let's see. Specify 0. Yeah, it doesn't say whether or not this is host order or network order. So let's just enter a bug for that. We love feedback. .stl.org, stlnet, create a new issue. Actually, let's look and see if there's already an issue. Nope. All right. Oh, goody. Two-factor authentication. And I have my code. Okay, new issue. Let's try that again. Datagram socket. doesn't document port NDNS is a port specified in host order or network order. And let's go look at the code and find out. Create datagram socket is taking the port and just stuffing it directly into the address. So that needs to be network order. So just document that here. It looks like this should be network order. We should document which order that uses, and however it makes sense to use host order here. So we should probably byte swap inside the function instead. So this is just here as a reminder. Again, the SDLNet API is not finalized yet, so I'll probably have to go back later after this is changed and change this function, but that's fine. So close that. So we're going to set the port here, and then we're going to call this function, create datagram socket. And that is going to be bound to the local port, and we need a local address. Interesting. Get peer address. Okay. Can we pass null? I believe we can. Just double check the docs. Address or null to listen on all available local addresses. That's what we want to do. So we're going to do null and a specific port. And then, why is it complaining about GNetFD? Because this should be a pointer. Okay. There's no such thing as the socket set. So we are going to allocate one here to make this simple. Remember how we set our socket set to a bunch of void pointers? We're going to actually have an array of real void pointers that we'll use there. So we have max players. We'll use that as our maximum number of void pointers. And then we don't need to allocate this anymore. So oh, you know what? This actually is an assignment. Okay. Okay, we'll come back to that. Socket set 0 equals GNetFD. And we might need max players plus 1 for our local one, but we'll see. Okay, so then getting our peer address. Unfortunately, there might be multiple peer addresses, so this old code might not work the way we expect. And also, I don't see any way of getting the address that it's bound to. That also seems like an oversight. Get stream socket pending rights. We don't want stream socket stuff. Let's go back up to the addresses. So unref address, get address status, wait until resolved, resolve host name. Okay, let's come back to that. Since we're looking at addresses, let's go back up and fix our address resolution code. Resolve host. And I believe this got changed into an async call. So we call resolve host name. And port number. Port number, I guess we add later. Let's take a look at the code and see what that does. I don't see ports. Telnet. Resolve host name. Oh, wait. I have a project for this. Okay, so that sets the host name as to resolver, wait to resolved, then get address status. What does the resolver do? Resolver thread will resolve address, unref address, cast condition. So what does the resolve address do? Fills in the host name and doesn't do anything with the port. Yeah, so we need to fill in the port separately. So that function was resolve host name. Then this returns a server address. So the server address will be a pointer. These will also be pointers. Resolve host. And then wait until it resolves. Resolve host name. And then for the purposes of this port, we'll just block indefinitely. And then wait until resolves returns an int. One if successfully resolved, -1 if it failed. All right, so if less than 0, and we print our error message and return. And then we need to set the port. So serve header port. Hello? Is opaque. All right. Oh, get local addresses. That's probably what we want to use with create data and ground socket. Well, maybe not. Okay. Free local addresses, stream socket. How do we set a port? I guess that's done implicitly when we create the socket later. Okay. Okay, we're going to do the same thing with player addresses. Port num is a local variable. Huh. Interesting. Okay. Port num, server addresses. Let's see where we use that. TCP open. The address server. You know what? I'm going to stub that out. All right, add player. Player address, player num, host, port num, yeah, that port num is going to bite us. Where do we actually set data? The port. Check sockets, receive, channel, receive, okay. I'm just going to zero this code. We can come back to an address server later. I'm just going to work on the UDP stuff. I'm just scanning the code to see what our usage patterns are here. Okay. Because up here where we're setting players, we are not setting the port. But later, when we send to them, we're going to need the port. Okay, so let's finish resolving this. Then no, specify local player. No. Can we pass null in, or do we need to actually specify localhost? Looks like that actually takes a host name, so we'll use localhost. Okay. Okay. So here, get peer address we haven't bound yet, so we can't really do this here. Actually, instead of localhost, let's use localhost. I wonder if we have done this above. Let's comment this code out and set a breakpoint here and see what happens. Okay. So here we're writing data into a frame. That probably doesn't exist anymore. Yep, okay. So we're writing a 32-bit value. What did this used to do? Let's take a look. STLnet. And then let's look at the STL2 branch. And then look for write 32. Did this convert it to network byte order? That's not helpful. Was it done in the header? Yeah, it was in network byte order. Okay. For the purposes of this demo, I am not going to write it in network byte order. Oh, actually, hey, it would be kind of cool if this were network compatible with the old version. So maybe I will. Right. Let's see, how fancy do we want to get here? What kind of data are we pushing? So I'm going to read the frame number. I'm going to send the outbound frame. And here, I'm going to write the frame into the outbound buffer. Okay, and outbuff is buff and bufflen. Okay. Okay, so we're just going to use that header code here. Boom. Area P is that. And our value is frame. We're going to do that again here. And feed. All right. So why is it complaining about that? Let's go ahead and build this and get the actual error. Okay. See. Oh, yeah. So we stored the port in here, and then we use that for binding. And that's our player. It's the one that we want. Okay, so we'll have to come back to that. That's fine. Swap 32BE is what we want. Got it. All right, much better. Okay, and here this is going to be the same thing except for reading. Copy this. So buff1. And that's instead of swap B 32, it's going to be 32B. I'm not sure what we're going to do with the channel stuff here. We might have to track the channel separately. Fix these to bufflins. Read 32. You know what? I am actually going to undo this and re-implement those functions. The code will be a little bit cleaner and it'll be clear what's going on. So we're going to rewrite a little bit of STLnet 2 on top of STLnet 3. And then I will go bug Ryan because I don't want you guys to have to do this later when we actually ship. Okay, do those errors go away? Let's see. Yep. Maelstrom doesn't exist anymore. Maybe we don't need to fill that because when we receive a datagram, it's going to be allocated inside of here, so we don't actually are sent It's actually going to be a pointer, so we don't need to fill that. Okay, so sync network. We've set our frame number in the packet. We're going to send this to all of the players. And the way to do that is send datagram. So it takes the socket, an address, a port, and the stuff. Okay, so we've got socket. Where's our player addresses? G player something. Let's see. G player adder. I'm going to throw some ports in here. Static. We had 16. Play port max players. And that's going to be our solution for where do we store our ports. To play pattern. Didn't get that right. Hang on. It's not G. Okay. Play adder. The original call. I think we have to send them individually. Yeah. Yeah, we have to send them individually. Okay. Left index. Index. Play ports. Index. And then outbound buff. Dot buff run. Then why is it complaining about that? Because it is a pointer, but the outbound ones are not. I think we allocated these here. They are pointers. Okay. Okay. So here, let's do this again. Index +1. I hope Brian is watching this and taking notes. All right. These are sent. This is, I believe, was a channel. Double check that. UDP send. Yeah, channel number. You've lost the idea of channels. That's a bummer. Okay. So this is phone is our player. So we're sending it to the server. All right. Well, this is getting long. So I think what I'm going to do is I'm going to stub this out for now. The fact that we don't have channels means we have to build channel infrastructure, which is kind of out of scope of this demo. But return, what did we return? 0. 0. Okay. What else needs to be fixed here? 0. Fix me. Send new game. Return 0. 0. Fix me. Okay, so we won't actually be able to play a game when we're done here, but we'll be able to launch it and make sure that the UI works. And to wait new game, F1, fix me, return 1. Actually, this probably return 0. Yep. Return 0. Okay, so let's build this and see what happens. Aha! Again, our comparison with 0 for bool. This returned bool. Now, okay. And then port must have class struct union. This is play ports. Or current player. And then back up here where we were resolving ports, let's go ahead and just set port. Play port player num equals so swap 16 port num. And this, I believe, does the same thing here, except we don't have a port num. Do we? Yeah, there's a value. We'll use it. Okay. Go to scores server is TCP socket. Yeah, we're going to stub all this stuff out too. Zero. Score server isn't even running anymore, so this is fine. Stub, stub, sub. If one, we're just going to do this. Couldn't connect to the score server. And this. Okay, this we don't need. Okay. Let's see how that works. Okay, so we have a bunch of complaints about headers. What is that? STLnet.h is STL3. STLnet version not found. Where are we getting this complaint? Okay. Well, I see down here that stl2.lib is not linking. Let me see the actual output. Oh, that was just an old warning. All right. So stl2.lib is the actual error that we're running into. So let's fix that. It's now stl3.lib. So we go to the linker, input, and we're going to change these dependencies here. So it's stl3.lib, stl2main.lib doesn't exist anymore, and we're going to need stl3net.lib. And we're going to go ahead and need to make these changes for all configurations, so debug and release. So here, boom, done. Okay, so let's build this, see what happens. Win main, haha. Okay, so remember how we removed stl2main.lib from our link library? In stl3, that is a single header library. So we're going to go to our main function, perhaps main.cpp. Just double check. Hello. Where's our main? Yep, here we go. Okay, so at the very top, in addition to stl.h, we also need stl3 main.h. And that provides the main implementation that we need for, that it's complaining about here. All right, so we compiled it, we tried to run it, it couldn't run because stl3.dll isn't there, and that's fine because we are actually going to copy this over into our game folder. So here in Maelstrom, we're going to copy this over. Ports, Maelstrom, Visual C, debug, maelstrom.exe. We're going to copy it over, and we have stl3.dll sitting there, but we're going to need stl3net.dll. Pardon me. So grab that, copy that over. Let's try just running it. Hey, that's promising. So we have audio. Our bitmap fonts are backwards. That's not bad for a first start. Okay. So the first thing we're going to do is just move the stl2 DLLs out of the way. So we know for a fact that we're just using stl3 here. We're also going to debug this. So we're going to Maelstrom debug properties. We're going to set our working directory, instead of from our project directory, we're going to set it to the directory that we're running from over there. So browse, desktop, Maelstrom, that's going to be our folder. So let's just double check that. and make sure that runs. Nope, not found. So what happened there? STL3DLL, STL3net.dll, working directory, command line arguments, command. So we probably need to grab these and put them into the place where we are linking this. So we've got ports, Maelstrom, Visual C, debug. Let's throw it here. I'll try it again. That worked. Okay. Okay, so we set our socket set. Net FD was something reasonable. We're not going to use it yet, but that's fine. And it exited. And why did it exit? Okay, initialization failed. Let's look at our output. We have no output. Let's set our next statement over there and step through, see why initialization failed. Load scores, joysticks, and we couldn't load the fonts. So maybe our directory was wrong, because they're right there. Maybe that's why we couldn't find STL3.dll. So next statement. We're getting our path. Our path is /. So that's working off the current directory. Oh, looks like we have some path manipulation going on here. And we're looking for things in various directories. So let's see where we're trying to load it. Okay. That's not going to work. Let's see. So let's set some breakpoints at these various fopen points and see which one should be succeeding. So that's not that one, not that one. That should work. So, and it does not. So let's set our next statement there. Set our next statement there. Open. New name is Maelstrom fonts. Let's just triple check this. Oh, it's Maelstrom _ fonts. So where do we handle the translation to underscore? Not here. Macros should be here. Oh, because we're not on the second iteration. Okay. So this is _ fonts, _ fonts, _ fonts. So this one, in theory, should open. But it doesn't. So my theory is that our working directory is not correct. Let me see if there's a chdir call anywhere in our code. So, current working directory, maybe? Nope. going to try a trick to see if I can get the working directory. So let's get our debug window, or watch. And let's look up the function signature for get current working directory. Get pwd. Get working directory 132C. Get current working directory, but that needs a buffer. Here we go. That also needs a buffer. Get current working directory. WD. No, there isn't a version that works that way. All right. Let's see. I wonder if Process Explorer will tell us. Hello. Process Explorer 64. Let's do 32-bit since it's a 32-bit process. I agree. Let's see. We've got services, Explorer, devenv, WSL. Where is Maelstrom? There we go. Current directory. Well, there you go. That's not right. I bet I did something silly. All right. Let's go back to where we dropped our DLLs. Put them back into the Maelstrom folder. Go back to our debugger. Check our properties. I set the working directory for the release configuration. Yeah, that won't work. If I set it to the debug configuration, that will probably work much better. All right, so we have a bunch of breakpoints set. Let's see what happens. This worked. Let me clear this, clear this, clear this. Hey, there we go. Okay, so let's fix the bitmaps. So that was index 1 MSB? I don't remember. We'll find out. So I believe because these are Mac resources, these are using MSB, most significant bit. So let's try that. Clear this breakpoint. Okay, that's much better. We should fix the font color here. So it's probably something in the palette code that we were working on. So that's in Mac dialog. Actually, get surface palette will give us all the places that we changed. Okay, so this will be, let's see. Actually, this will probably be fun stuff. So we have set palette colors, foreground and background. Our background is set to what? Passed in. This is invert text. So let's see if we hit this. And let's also run this in a window so that we can debug more easily. So let's go back to main. Look at the command line arguments, dash windowed. So debug configuration, double checking that. Run windowed. And let's set a breakpoint at here and here. Wow, that's really small. Okay, so background is white and foreground is yellow, looks like. The alpha is 0. Alpha is 0. That may not matter. That might be okay. This is the intro screen, so we know that text was okay. And then this is the main screen. So the text we're drawing here is the high scores, so that's fine. Let's jump down to where we actually draw the buttons. Draw key. Let's take a look at that. How does draw key work? So we grab a font, draw the icon, and then we draw text. So what does draw text do? So the foreground here is 255, 255, 255. Create surface. We can do a bunch of work to load up the bitmap. Then here, well, I just did send next statement instead of continue, but that's okay. So background and foreground, 255, foreground is 255, but alpha value is set. That doesn't seem right. Why is that? Background, foreground. Ah, I didn't initialize the foreground. That might not actually be the problem, but that doesn't hurt to do. And just for grins, I will use that here as well. Okay. Okay, that's still not right. So we go here, go back to draw key. Style bold. So we do foreground is white, background is black, and then we draw yellow. For the text. So that yellow doesn't look right either. Okay. foreground. Got a text image. Cue this for blit. Format MSB. We've got some observed data, ref count. Okay. So that looks fine. Then we free the text, which will not actually destroy the image because we have a ref count already. So it looks like something in the mapping between the RGB colors we have here and the RGB colors in the palette. So I have an idea. frameref.cpp. When we finish, got load image, grab area, draw rect, draw line, set palette. I wonder if these set palette calls that we did needed to be distinct palettes. So dialog code is fine because it's the palette from the new surface. Same here. Here we're setting the same palette for both the screen, foreground, and background. I wonder if that was a problem. I'm going to stop here for a second and just do a commit. So we've got a bunch of changes queued up here. Let's go ahead and save our work in progress. Maelstrom, STL3 port in progress. Okay, and now let's show that commit and just search for the frame buff stuff. Frame.cpp. Okay, so we created the background, we created this staging surface. Where is the palette? So here we created the palette. So we didn't actually change any of the palette handling there. So this code is the same. And they actually do share the palette, so that's fine. And then we set the colors, we set the palette. Let's go look at that. Actually, we know that's fine because all of the images show up correctly. So what we want to do is set palette colors, set background, setting up our color map, perform blitz. All right, so we've got our blit queue, blitz surface unchecked. So I'm guessing what's happening here is we have a bug in STL where we're mapping the bitmap into another palette and we're not getting the colors that we expect. So let's go ahead and get the STL source code, which we have here. And we've already built it. So let's grab that STL DLL that we built with debug information and drop that into our executable directory. As you'll see, 32 debug stl.dll. And let's jump over to our game directory, put it in there. That's not going to work because we're in the middle of debugging, so I'll stop debugging. Try again. Okay. And then let's set a breakpoint here. And we didn't hit our breakpoints there, so let's probably perform blitz where we iterate over the queue. And just for fun, we know the text that we want here. So this text, for example, is start playing Maelstrom. So we're going to go in here, and we're going to get our text image. And our text image pointer is that. So we're going to set a breakpoint over here where, and we're going to have a condition where the blit queue I source equals the pointer that we're about to queue. So we get exactly the blit that we want. And here we are. So it's going to validate the map. So we haven't done this blit before. This is a new surface. So this should actually be doing work. Let's see. And we are. We go into map surface. So our source format is indexed. What is our source format? It's index1 MSB. Our destination format is index 8. So they're both indexed. So it's doing, oh, source pal is null. Dest pal is something. So why didn't we have a palette on our source surface? Interesting. That's the problem. So let's go back to where we set our draw key. We're actually still in there. All right, great. Wait a second. Oh, ha. Okay, so we're actually drawing the next one, maybe? Anyway, so go back into draw text. And text image. So we create it. Let's set a breakpoint here again. Palette is null because we did not create a palette. That is silly. All right. That explains it. Let me look and see if our migration guide says anything about creating a palette. Pixel format has been renamed pixel format details and just describes the pixel format. It does not include a palette for index pixel types. Let's look at create surface. Oh yeah, look at that. Our example is creating a palette. All right. So what did we learn? Read the docs, even if you think you know better, because I thought I did. All right. So let me just look for everywhere that we do get surface palette, because I think we have to fix this in a bunch of places. So this should be changed to create surface palette. This button has already been created, so here we're just getting the existing palette. Okay. And label also was just created. But I'm going to assert that we have one. And here. And here. This icon we just created, so this is create surface palette. And here. And here we're using the existing text, which has a palette, so we're just going to get it. So I'm going to insert. And also protect this. Okay. Create surface. We need to create one here. Set surface palette. Oh, we don't actually need to create it because set surface palette will indeed set the palette to this one, not create a new one. So that's what we want. And I believe that's the same here. Yes. Which is why our artwork looked good. Okay, so now let's try this again. Okay, clear this. Actually, just make sure we have a palette for sanity's sake. Yep. And I am so confident this is going to work. I'm just going to remove my breakpoint. Look at that. All right. So our text is all the right color. Our buttons are all the right color. If we go into a dialog, this all works.
Hot damn.
All right. So it took us a little while. We have more work to do to port over the networking, and I will probably do that after I learn more about the changes. But here you go. That's the initial port of Maelstrom to SDL3.